Let's talk about writing radical equations. Now, typically when we talk about writing any equation, it's like we're going backwards. It's from start to finish with the steps that we've been learning, and it's really no different here with radical equations. In fact, I think you'll find that it really uses all the same ideas. Particularly when you look at what is true about the graph over here, you discover that it's got a vertex, and that vertex still becomes the main point when it comes to thinking about what's true about the equation for this radical. In fact, you see how you can take your -6 and very quickly say that you then would have an x plus 6 under the radical. And you see how we can take the 1 from this vertex and very quickly say that we would have a plus 1 on the outside of the radical. And just like that, it appears that we have an equation written. And in fact, we do. But there's one more thing to think about with this graph, and that is that a point has been given to us. And you see that point is going to end up helping us to determine the exact stretch or compress, in other words, the exact a value of this equation. So we put the letter a here, and we take a little work to solve for that a. And of course, that little bit of work is just to plug in the point. Notice that I'm plugging a 5 in for y, and we're also going to plug this -2 in here for x. So we're taking the point, we're plugging it in, and ultimately we will then be able to solve this equation for a. Now, when you solve this equation for a, you just kind of work out from the math. In other words, the -2 plus 6. Now, of course, that's going to come out to be 4. So we're going to be taking the square root of 4. But the square root of 4 is something that can be computed. That, of course, comes out to be 2, which really gives us 2a. And we're only a little bit of math away from knowing that a would equal 2. Now, once we have a equal to 2, then we can say that we really have our full equation, and your full equation in this y equals form is going to be, well, the a value of 2, and then the square root of x plus 6 plus 1. Notice that I'm not filling numbers in anymore for x and y, but I'm writing them as variables so that we can have our equation for this graph. Now, if we want to be super sure that this graph is right, we can always, as we've did the other day, we can always find an additional point, maybe like the point 3, 7. The reason I'm looking at this point is because I can actually plug this in to my equation to verify that my numbers are right. If I plug in a 3 and a 7, and again do a little bit of math, we find out that the square root of 3 plus 6 is really the square root of 9, and the square root of 9, of course, is 3, and 3 times this 2 is going to be 6, plus this 1 indeed is 7. All this is a simple way to say that my equation is correct, because if I plug in an additional point, it satisfies. So it's all about taking the equation that we studied yesterday, that is y equals a, the square root of x plus or minus h on the inside, then plus or minus k on the outside, taking that equation and plugging in the vertex, and then plugging in that point to x and y, so that we can ultimately solve for a and end up with our equation. As I did do up here, you can pick another point. You can kind of pick a test point just to make sure that everything is right, and know that you have that final answer. You want to try it one more time? Trying to write an equation. What if we're trying to write an equation from, say, like a table? A table of values. Well, keep in mind that a table of values is really nothing more than just a graph, of course, in number form. So we can plot some of these points. I think it would be wise to plot them. It helps you to see the graph. And of course, once I can see that graph, at least see the pattern of that graph, I can then connect the dots in order to see that actual square root radical graph. Now, really, the problem from here follows just the same as the one up above. Once again, using that vertex as our main point, it's pretty easy to see that the vertex was the first point, and I can jump right into plugging that in for h and k into my formula. You might as well put the letter A there. You know that you're going to have the letter A. Make sure that you use a +1 because we actually shifted to the left, but we'll also use a +6 because we shifted up. Whenever you're ready, you can plug in any one of these points. You know, I don't have to plug in the next point. I can plug in any point that is shown on this graph. So there's no reason I can't plug in 3 and 2. Just make sure that you plug that in very carefully. The 2 for y, and of course the 3 for x. Just make sure you get the order of all that correct. But from here, you're just solving for a. And as you solve this for a, you think about the math that you can do. You can do 3 plus 1. You can do the square root of 4. Of course, the square root of 4 is 2 again. And you're just a hop, skip, and a jump away from your a value. It looks like that a is going to equal -2. Make sure that you realize that once we know that a equals -2, that we can actually fill that in to our final answer, to our final equation. And so your final equation is going to have a -2, the square root of x plus 1, and +6, just like we had before. Now, you know, the negative that we got in this answer, that should make you happy as we see a graph that is reflected. It was reflected the moment that we drew it because, of course, it's going down. So it sounds good that we have this negative sign. But if you want to be super sure that everything's right, you can always plug in another point. You know, you could go back and you could take this point 0, 4. Nice thing about plugging in zeros, as we just did in the warm-up, it's easy to do. When I plug in a 0, I find out that I'm actually going to be taking the square root of 1. That can be done. The square root of 1 is still 1. So that comes out to be just -2 times 1 plus 6. And yes, that does equal 4. Simply, we have confidence that our answer is correct. All right, so we end up with y equals -2 the square root of x plus 6.